Okay, so we have this table here, and pretty much we have to draw a state table using this FSM model. So first thing we're gonna see is that this is a Moore machine because our outputs are dependent on only our states. So see how the outputs are inside the states? So that means it's only dependent on the states. So what we're gonna do is start off with the following. We're gonna draw a state table. So we'll have current state. Then we're going to have next state when W is 0 and when W is 1. And then our output is actually going to be our output's going to be the largest because look at how many different types of outputs we have. We have an R2 output, an R2 out output, an R3 in output, an R1 out output, an R2 in output, and so on. So it's going to be something like this. We're going to put R2. Let's start from R1. Let's start from R1 out, then R1 in, then R2 out, then R2 in, then R3 out, and then R3 in, and then there was an output called done. Okay, so let's start off at state A. So when we are at state A, what is it? So when we press W is equal to 0, we see we loop back into A. So we'll put A here. When W is 1, we go to state B. Okay, so when we were at A, what was our outputs? Well, we see there's something called no transfer, so that pretty much means no outputs. So we'll just put 0 for all of these. Okay, so now when we're in state B, when we press W equals 0 or W equals 1, we go to state C. Okay, but when we're our output, we see R2 out and R3 in are 1. So R2 out will be 1 here and R3 in will be 1 here, and everything else will be 0. Okay, now let's see. Now we go to state C. So when we press W equals 0 or W equals 1, we go to state D. And when we're at state C, R1 out and R2 in equal 1. So R1 out, so this will be a 1 here, and R2 in. So there's a 1 here, and everything else is 0. Now the last one is when we're in D. So when we press W equals 0 or W equals 1, we go to state A in both cases. Okay, and we see R3 out is equal to 1, R1 in is equal to 1, and done is equal to 1. So this one will be 1 here, this one will be 1 here, and this one will be 1 here, and everything else is 0. Okay, so this is our state table. So now we have to draw our state assigned table, which everything has to be in binary format. So we'll put current state here, next state, and then our outputs. Okay, so current state, it's going to be in forms of 2-bit binary values. So we'll put y2 and y1 here. A will be represented by 0, 0, B 0, 1, C 1, 0, and D 1, 1. And for this one, it's going to be W equals 0, W equals 1. Next state will be represented by uppercase Y2 and Y1. Okay, so it should be 0, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, and then 0, 0, 0, 0. Okay, so now we have to find formulas for our next states and all our outputs. So our outputs are actually going to be the easiest ones. So we see R2 out and R3 in should be equal to each other, and they're going to be related with this. Okay, so they're pretty much going to be equal to the state value over there. So we're going to pretty much say R2 out is equal to R3 in, and that's equal to Y2 not times Y1. Okay, so you see how that matches the case, because when Y2, since in this state Y2 is 0, so this displays out 1, and Y1 is 1, so this displays out 1 as well. Okay, and this equals these two. But in other cases, R1 out will not equal this, because so when we put 0 and 1, we get 1, which is not what the value we're trying to get. The next one, R1 out will be equal to R2 in, which will be equal to Y2 times Y1 not. And then the next one, it's R1 in is equal to R3 out is equal to done, and that's equal to Y2 times Y1. Okay? Now we just need to do K-maps to get our uppercase Y values. So we'll do K-map. So we'll do W here, then Y2, and then Y1. Then we do 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. Okay, so since this is for Y1, we're going to pretty much focus on this row and this row. Or sorry, column. So when W is 0, at 0, 0, Y1 is 0. At 0, 1, Y1 is 0. At 1, 0, Y1 is 1. And at 1, 1, Y1 is 0. Now for W equals 1, it's 1, 0, 1, 0. Okay, so something like that. So let's see how we can group these. We can group these two together, and we can also group these two together. So Y1 will be equal to W times Y1 naught plus Y2 times Y1 naught. Okay, so now let's do the K-map for Y2. So it'll be W here, Y2 and Y1. So 0, 0, 0, 1, 1, 1, and then 1, 0. So 0, 1 here. So we're going to be focusing on these ones. So W equals 0 is for 0, 0, it's 0. For 0, 1, it's 1. For 1, 0 is 1. And for 1, 1, it's 0. And then the other one is 0, 1, 1, 0. So we circle these two. And Y2 should be equal to Y2 naught Y1 plus Y2 Y1 naught. Okay? Now let's draw the circuit. So we'll have 2D flip-flops. So we connect the clocks together. Okay, so the output here is pretty much supposed to be your lowercase y values. and the input here are going to be your uppercase Y values. So put Y1 here and Y2 here, and here will be lowercase y1 and here will be lowercase y2. Okay, so let's see what we can do. We can do our outputs actually. So we can connect y1 here and the NOT of y2, use the AND gate, and the output here will be r hold on, let me r2 out and r3 in. And then another one we can do is take y2 and y1 NOT, connect them. This one will be r1 out, and this one will be r2 in. And the last one, we just connect y1 and y2, connect these two, and then we get three outputs, r1 in, r3 out, and done. Okay, let me draw this more properly. There we go. Okay, so now we have to do y1 and y2. So let's see, for y1, let's have an input called w, and oh yeah, wait, there should be a y1, there should be a 1 here. Sorry, I forgot to include the 1 there. But anyways, so w and y1 NOT are connected like this, and then we have y2, so we'll connect the y2 here, and y1 NOT, so we'll connect this here, and then we add them together, so we can use a OR gate and then connect it to this. Next, what can we do? Okay, so for y2, it's wait, that's pretty much an XOR gate. Yeah, so we can actually just use an XOR gate and connect y2 and y1. So we can connect y1 into an XOR gate and y2 into an XOR gate, and we can just connect it like this, and that should be your circuit.